This is another problem based on the law of conservation of energy. Okay, let us see what is the problem. While at the county fair, Katie tries the water slide whose shape is shown in figure. The starting point is 9 meters above the ground. She pushes off with an initial speed of 2 meters per second. If the slide is frictionless, how fast will Katie be traveling at the bottom? Okay. Now, as I told you, this is based on the law of conservation of energy. Therefore, E initial must be equal to E final. Okay. What is the initial energy? Katie is pushing herself with a velocity of 2 meters per second. She is at a height of 9 meters. So Katie has both the kinetic energy and gravitational potentiality. So Ki plus Ugi is equal to Kf plus Ugf. Okay. And now we know K is equal to half mv square. And then Ug is equal to mgh. Okay. And then here we have initial velocity is equal to 2 meters per second. And then initial height is equal to 9 meters. And then V final we have to find out. And then H final is equal to 0. Therefore, H final is equal to 0 means UGF is equal to 0. Okay, rest of the things will be there. Let us write the equation. Therefore, half mvi square plus mgh I is equal to half mvf square plus 0. Okay, we have to find out vf. Now, mass goes off from the equation, and then vf square is equal to vi square plus 2ghi, or vf is equal to square root of vi square plus 2ghi. Substitute the values. Vf is equal to square root of 2 square plus 2 times 9.8. G I am taking 9.8 and hi is equal to 9 meters. Okay. So this gives a value of 13.43 meters per second. This is the velocity with which it is sliding at the bottom. Hope this helps. Thank you. Bye-bye.